Hey y'all, welcome back to another video with me, Miss V. Today I want to go ahead and talk about a proof of the Pythagorean theorem. So in my last video, I talked about what Pythagorean theorem was and how to use the formula for Pythagorean theorem. And just a reminder, I'm just going to go ahead and write the formula up in the corner here in purple. But today we're going to go ahead and talk about how to prove one way to prove Pythagorean theorem, because there's multiple ways to do this. So if we take a look at these two diagrams, we have two squares represented here. This is square X and this is square Y. And essentially we want to go ahead and fill in these different regions to figure out what the area of each section is. So area 1 is this area here, area 2, 3, 4, and 5, okay? So let's go ahead and start off with area 1. So if we zoom in here, we know that area 1 is a triangle. So we have to go ahead and use the formula for the area of a triangle, which is 1/2 base times height. So I'll go ahead and write the area of a triangle formula in the corner here, just to remind ourselves of the area of a triangle. So it is 1/2 base times height, or base times height divided by 2. We also have the area of a square, which is just base times height, okay? So area number 1, if we take a look at this triangle here, we have a height of B and a base of A. So the area of that section would be A times B divided by 2, or 1/2 A times B, because A is our base, B is our height. Just plug it in here for our formula for the area of a triangle, and that's what we get. Then area 2, if we look over here, section 2, this is a square where both of the sides measure A. So area 2 is A times A, which is the same thing as A squared. Over here, area 3, we have another smaller square with the side lengths measuring B. So the area of this square is B times B, or B squared. Okay. And now we're going to go ahead and move on to area number 4 in square Y. So again, area 4, kind of the same thing as area 1. We have a height of B and a base of A, or a base of B and a height of A, doesn't really matter. So area 4 is also going to be A times B divided by 2. And finally, area 5, we have a big square with side length C. So the area of that square is C times C, or C squared, okay? So this was the first part, and I want you guys to also notice that square X and square Y are the exact same square. If you look here, one side of square X is A and B. Same thing over here for square Y, A and B. The other side is A and B. The other side for square Y is also A and B, okay? Or A plus B. So they're the exact same size squares. So now we're going to go ahead and use those areas to help us prove the Pythagorean theorem by filling in these statements below here. So we know that A and B are the lengths of the legs of your right triangle, and C is the hypotenuse. So we're going to go ahead and justify each of these statements, okay? The first couple are given to us. So each side of each square is divided into the same two parts, A and B, given, and squares X and Y are congruent, that is given to us. So essentially what I was saying, where you have each of the sides is A and B, and we know that they're congruent, okay? So that means that since the squares are congruent, then obviously their areas are going to be congruent because they're the same exact square, okay? Then to get the area of square X, right, if we look at square X, okay, the area of square X is basically everything that is inside of square X. So we have area 2 in here, we have area 3, but we also have 1, 2, 3, 4 area 1s, okay? So we can multiply area 1 times 4 and then add area 2 and 3 to it to get the area of square X, which is essentially what's right here. And then finally, you go ahead and simplify. If you do 4 times AB over 2. This is the same thing as 4AB divided by 2, because you multiply the 4 to the top number. And again, 4 over 2, this simplifies to 2, which is how over here in this second line, they got 2AB, okay? So our justification for that is add each area in square x and simplify, okay? The same sort of thing is happening with square y, but in square y, instead of having a and b, we have c squared. And again, area 4, we have this area 5, which is our c squared, and we have 1, 2, 3, 4 area 4s that make up that square y. So that's how we get over here 4ab over 2. And again, simplify the same way I just did. So your justification, add each area in square y and simplify. Okay. And now finally, since we knew that the areas of the squares were equal to each other, we can go ahead and set up an equation here. We have the area of square x equal to the area of square y. So your reason would essentially be substitution. You would be substituting from this statement up here, statement 3 or step 3. So substitution from step 3. And then finally, if you look at the equation we have, if we subtract 2ab from both sides, we cancel that out on both sides, and we end up with this formula here. So you would say subtraction subtraction property of equality. Or just say subtract 2ab from both sides. It's the same thing, okay? So this right here is essentially one way to prove Pythagorean theorem. Later on this week, we're going to take a look at a different way to prove it. But this is one way to prove that Pythagorean theorem is true. So if you guys have any questions, you can go ahead and leave any comments you need to below, and I'll get to them as soon as I can. But thank you so much for watching another video, and I will see y'all in the next one. Bye.